All right, so you were lucky to get the Java release preview demo yesterday, and we had a lot of features on the multi-cloud and the Delphin front, that is the heterogeneous storage performance monitoring platform. Today, we also have for you another demo from the SODA development team, and this one is on the features of ODF for container storage. I have with us Mohammad Asif Siddiqui, maintainer and architect at SODA, Amit Kumar Roshan, maintainer and architect at SODA, Jasmeet Singh, we the software design engineer at Click2Cloud. Over to you, the three of you, for the demo.
And welcome to day 2 of SODA Global Conference. In this session, we will be covering few of the important features of ODF for container storage. And we will be dividing this complete session into 3 parts, where in first, we will give a demo of SODA CSI plugin. And in second, we will try to cover CSI plugin play. And in third, we will try to see what are the disaster recovery solutions for container storage. One thing common across all of these demos will be like user will get a similar experience for all the container storage solution of ODF, irrespective of which type of drivers are used underneath. So let's get started. So my name is Asif, and I'm a senior system architect at Huawei. I'm also a SODA maintainer and an ASF member and mentor for a couple of ASF projects. Along with me is Jasmeet and Amit. So over to you, Jasmeet.
Hello everyone, my name is Jasmeet Singh. I'm a software developer at Click2Cloud. I basically handle file, block, and CSI types of storages over here. So I hope you enjoy this session. Over to Amit.
Yeah, hi all. This is Amit. I'm a senior system architect and I'm a SODA maintainer as well. So yeah, I will be going to take session on CSI plugin today. Yeah, over to Asif. Yeah.
Okay, Amit, I will stop sharing my screen so that you can start.
Is my screen visible to all?
Yes, Amit.
Okay. Yeah. Hi guys. Once again. Before jumping into the CSI plugin feature of SODA, let me just take you through SODA framework. So SODA is an open source data framework which handles unified autonomous data end to end. And with the recent development in the workload deployment, container is a de facto standard currently. And so there is a urge for each and every container storage to present itself so that storage volumes can be consumed by the container workloads. Now, considering this scenario, industry came together and created a standard called container storage interface, wherein each and every storage system can be provide an interface can be consumed by the container workload, and this is platform agnostic as well. But considering these all developments, there are some gray areas, like if somebody has to handle the heterogeneous storage system, then there are deployment complexities, there are maintainability complexities, and there are some scenarios where advanced features are not standardized, like data protection and maybe data mobility, or maybe monitoring system. So considering all these scenarios, SODA Foundation did a collaborated approach and created a unified heterogeneous storage system, wherein the core modules are API, doc, and controller. So API provides a standard data and storage management interface. A controller is gonna do the management of metadata, some configuration management, and some scheduling and bookkeeping features. Now there is a module called doc, which is like different storage driver put together in a single unit, and that's where all the magic going to happen for handling different heterogeneous storage system. Now, considering all these modules, which is gonna create a heterogeneous storage management system, but this complete system has to be get exposed to the containerized workload. So that's where northbound plugin modules comes into picture, which makes this which is actually a wrapper on top of this complete heterogeneous storage system, and which makes this complete storage system agnostic to different orchestration system. Maybe it could be Kubernetes, OpenStack, or VMware. But underneath NVP do supports CSI plugin. For that, basically the SODA CSI plugins are divided into two. One is a controller plugin and one is a node plugin, and they handles controller service and the node service of CSI standard. Now, underneath each and every plugin are gonna eventually end up calling a SODA API, which is gonna with the help of controller and doc eventually create volumes required for a workload in heterogeneous environments. The beauty of this architecture is these all drivers which we are seeing currently are raw drivers. There are no CSI standards being put around, nothing. These are just raw drivers put together into doc unit, and then it is exposed, and it is working very clean. Now, this is enough talk. Let's jump onto our demo. So to present a demo, okay. We have VM called SODA VM, where the SODA framework is deployed. So if you see, this is API server, a controller, and docking unit. Now there are some jargons in SODA framework, like we have a something called profile, which is actually a representation of a storage unit which is being handled inside the SODA framework. So currently for block, I'm using LVM, and for file share, I'm using NFS. Alongside this, there are a couple of other jargons like pool, so which is actually how much of volumes are available for respective profiles. If you see the profiles, this profile, this is 10 GB of total capacity is available, and currently is one thing is being used. I mean 1 GB is being used, and if you see the NFS, the 10 GB and 10 GB is available. Total capacity is 10 GB and 10 GB is available. We can also list down all let's say volume list. So if you see, this is one of the PVC being created. I mean, volume is being created, and which is which is consumed by some workload, and it is under this profile ID. If you can see, this is a volume. And similarly, we have for file type storage listing of all the volumes orchestrated for different workload for file type as well. So for that, yeah, so currently there are no volume being created for file type. Now for I'm using KTES as an orchestration unit, so that I can deploy a workload and which is going to consume any volumes orchestrated by SODA framework. I'll just show you all the workloads being run. So if you see, these are the part of NVP plugin. So there are block type of plugin and file type of plugin for respective storage type. And if you see, there are I mean, if guys are aware of CSI standards, there are provisioners and node plugins, attacher and snapshot required for different different CSI gRPCs to be get handled. Now, if some workload, you want to devise a workload and workload, and orchestrating a volume for that workload, following are the objects which are required to be get uh, uh, added inside the system. So if you see, one is a storage class for Kubernetes, which is actually representing a profile of the storage sort of framework. So if you see, the profile is same as so if you see, this is file set profile, which is being represented in a storage class. Then we have a persistent volume claim, which is requesting 1 GB of volume from that particular profile, and eventually we have a workload which is gonna consume that orchestrated volume. So let me just deploy this complete resources. So if you see, we do okay. If you see that PVC is created and it is in pending state, until unless volumes are being created and attached to this PVC, it would be in pending state. Now you see the PV is created and definitely it would be bonded with PVC. If you see, this is the same PVC which is bonded with the P. So this is same PV which is bonded with the PVC. So yeah, now if you see from the SODA side, till now we do not have any volume orchestrated, but if you see now, we have one volume orchestrated into the SODA framework, which is been served as a volume for that particular workload. Now if you see, let's just see what is the status of pod currently. Now pod is running, and now let's jump inside, step inside workload and see whether the volume is available for that particular workload or not. Yeah, so I'm just stepping inside, and if you see the mount, this volume is available for that workload to be get consumed. So now for completeness of this complete demo, let me just delete this workload so that the volume should be freed. Yeah, so I'm deleting the resource. It's gonna take some time, maybe. Yeah, so if you see the node now, pod now, so pod is gone. Let's see PVC. PVC is not available now. Let's see PV. PV is also not available, and because we have deleted all workload and PVs and storage as well. Now let's see whether the volume is available in still available on the SODA framework or not. So if you see, there is no volume available. So this is the complete end-to-end demo for file share system. I mean, file type storage type for which can be orchestrated for a workload. Similarly, the block type is also block type can also be done. Maybe now alongside this, currently we are also working on some advanced features such as topological distribution of storage units and monitoring, as well as some data protection related stuff. So this is me from CSI plugin, SODA plugin. I would like to hand over this to this session to Jasmeet.
Is my screen visible?
Yes. Yes.
So like today I'm gonna show you the demo for plug and play feature of SODA Foundation. So basically, plug and play is a mechanism by which user can use the heterogeneous storages in a unified way. So basically, what it does, like as Amit was saying, like nowadays companies are moving to the containerized type of environment. So like industries are shifting towards containers. So the basic, or we can say the main perspective to shifting to this towards containers is like it's very easy to use. So in this, we need a persistent volume to persist the data. So to persist the data, industry has come to mutual understanding with this CSI drivers. But what was happening before, like if we are using one CSI driver from storage vendors, so we can only use that storage type only. To use it in a unified way, we have like developed this plug and play feature in which multiple CSI drivers can be used at one single platform. So in this, like we can achieve and we can use the SODA features with this CSI plug and play without making any changes in the vendor CSI. So today we're gonna look into SEP CSI arbitrary driver, which is basically used for the block volumes, and the other one is OpenEBS LBM. So the prerequisites, or we can say the requirement to use this feature is installation of Kubernetes version 1.17 above. And the second prerequisite is SODA Java release installation should be there. And the third is the SODA CSI provisioner image. So like this image can easily available at the Docker Hub, so anybody can like get a pull from Docker Hub with the version 1.4.0. And there are some other prerequisite for the specific CSI drivers. So this prerequisites is already mentioned in the respective CSI drivers. For CSI driver, we have this prerequisites, which we have already mentioned in our official website, SODA website. And for OpenEBS CSI driver, these are some of the prerequisites. We'll just quickly move to the demo of today's session. So we'll start with LVM storage. So in this, we just need to do one little changes. As you can see over here, like in this operator file, which is provided in the official OpenEBS website, they were using their own CSI provisioner. So what we have to do, we have to just replace it with our SODA image, which was our third prerequisite. So we'll change here with it. And file list, this profile is a concept of a SODA environment only. So in this first and third will be used for plug and play feature. So the second change which we need to make in the storage class. So as we can see, like all the deployments has been done successfully. Check the states. So it's in running condition. All the pods are in running condition, and we can also see the pod named as PO is also in running condition. So if we want to check the PVC, here we can see this is the PVC which is bounded, and this is a persistent volume. So what just happened over here, like we have created one pod and we have given persistent volume from this OpenEBS CSI driver. So second, like we just move to the SEP CSI driver over here. In SEP, we need to make some changes. We'll just give the cluster ID in a config map deployment, and here it's a cluster ID. And the second thing which we have to give, we have to mention our monitors. Like in this environment, I'm using a single monitor. So this is the monitor with the port 6789. And the second thing, this is a prerequisite. We are creating a user with the name of Cube, and we are giving user key. It's a secret key, we can say, into it. And the other change which we need to make is the same, like as we made earlier in LVM. So here also we just replace the official image of SEP with our SODA image. So as you can see over here, Apart from this, we do not like have to make any other changes in the vendor CSI. This is the only change which is required. This is the basic deployment which can be easily get from the official website, and these are some of this storage class. In the storage class, we have to mention a profile ID. This is the profile ID, and the cluster ID as shown in the official website only. And this is the pool name. The admin ID will be remain same, and this is the user ID which we have created for this deployment. We'll just start with the deployment. So all the deployments have been done successfully. We'll just check all the containers are up and running. So as we can see, this all the containers are up and running successfully. We just now deploy the storage class PVC and PD. Check the status. So it is showing in pending state. Just check the PVC. Yes, so now it is bounded. Check the PV. Yes, you can see the status over here. It's in bounded state, the second one. So this was our pod. It is running and has given the persistent volume from set cluster. So this is all from my side. I will hand over the session to Mr. Asif. So over to you, Asif.
Hey, thanks, Jasmeet, for this interesting demo. I will share my screen. We have already seen how we can use the existing CSI and non-CSI drivers using our plugins in Kubernetes. So now comes the problem of like data protection and disaster recovery, which is a very big problem for stateful applications. And challenge remains there for DR solutions in Kubernetes, as most of the existing solutions for DR are based on machine backup. But what we really need in Kubernetes is just to do the backup of the data, as the applications are already stateless. So to do an efficient DR solution, now first thing what we need to do is we need to define a efficient way to do a efficient way of doing the backup of the volumes or the snapshot of the volumes which we are mounting to the containers. Okay, and we need to make this solution a generic way, so that a generic way, and extract this feature above the CSI, so that any of the CSI drivers can seamlessly use this feature, even if some drivers which do not provide the snapshot features can actually use this solution and get those features inbuilt into the CSI without doing any change in their vendor code. Okay, so for doing this in SODA, we leverage the SODA profile to define the snapshot policies, and users can configure these all informations in the SODA profile. We have a custom tag where you can define these policies, and these policies can be used by any of the CSI drivers which are using CSI plug and play, which are using our SODA CSI plug and play mechanism. And for this, we have added a new component called SODA Syncer, which basically will give functionalities of snapshot, restore, or a data mover from one cluster to another cluster. And this whole solution is based on a time interval or an event based on the configurations what you do in the SODA profile. So this is the basic architecture for our DR solutions. And this solution is right now restricted to the local PVs, and we are working regularly to make it available for all other different type of storages as well. So in this, this is a typical deployment where on the left-hand side, we have a Kubernetes node, Kubernetes deployment where we have one CSI deployment. And on the right-hand side, we have a SODA deployment where we have a SODA proxy and hotpot. So SODA proxy is a component which helps you to connect to any of the SODA API server to get all the profile information. And here, if you see in the CSI deployment, we have our SODA CSI Provisioner. We have our SODA CSI Provisioner basically, which runs along with any of the CSI drivers which support local PV. So say if user gives a request to create a PV, right? So a SODA CSI Provisioner keeps watching for those objects, and based on the request, it sends a call to SODA proxy to get the profile information which is there in the storage class. Based on the profile information, it sends out a request to the vendor plugin to provision the volume, and parallelly, once the volume is created, it sends out a request to the SODA syncer to start the snapshot based on the configurations what are received in the profile. And SODA syncer internally uses Restic, which is like an open source tool for doing the backup of the local volumes to cloud. So SODA syncer sends a request to Restic to start the snapshot and send those volumes, send those snapshots basically to cloud. So let's jump to the demo. Okay. So here we have a sample application which has a storage class, and we are using the profile ID, SODA profile ID, and it's same as Jasmeet and Amish showed the persistent volume claim and the deployment. One thing different from the demo is we have the profile information. So this is my SODA deployment. So we have the profile list, and this is the profile which I'm going to use for the demo. So I'm just going to show the content of this. Okay, so this is the profile which we'll be using. And in this profile, one thing to notice is the custom properties. So in this custom properties, we have added the AWS AKSK, as we will be trying to send these snapshots to AWS bucket, S3 bucket. And this is the Restic configuration where we give the encryption password and also the repository information where exactly in which bucket we want to push the snapshots. And we configure at what intervals we need to send these backups. Like here I have configured like every 30 seconds, a new snapshot will be created and it will be pushed onto AWS cloud. And this is the driver name. So using this profile information, we'll be trying to deploy an application. Okay. And we are using OpenEBS LVM CSI driver for this demo. So let's deploy. Okay, so we have this pod running. We'll just check the logs of the syncer and see whether the snapshot has been created or not. Okay, so once the application is up and running, it will take 30 seconds to create the first snapshot. So here we can see the logs of this syncer. It has started taking the backup, the snapshot. And just for the sake of this demo, I have enabled the logs to see how it goes. And it's taking the mount point of exact mount point what it has been mounted to the container. Of the backup is done. And we can go to AWS S3 bucket to see whether the snapshot has been pushed. This is the bucket which I was using. So here we can see the snapshot is there. So one snapshot has been pushed. So we just wait for another 30 seconds to see the another snapshot. So see, after 30 seconds, the next snapshot has been started and it has been pushed. We'll just go back here. So here we can see two snapshots are there. So by this, what we are trying to say is, if any of the CSI drivers which do not have this feature, right, they can use this SODA CSI plug and play and this DR solution to get the features inbuilt. Because our whole solution is based on, like, we extract the features one step above the CSI so that everything, like all these features, can be seamlessly used underneath. So that's all for today's demo. Okay, these are some of our SODA GitHub links, and we are there on Slack as well as on Twitter. Thanks everyone.
Thank you, guys.
Thank you, guys. Thank you.
Right. Am I audible?
Yes.
Okay, awesome. So thank you, Asif, thank you, Amit, and thank you, Jasmeet. I believe we are actually over time. So if you do have any questions, please post them in the Q&A and we will take them up at a later time. But thank you for that in-depth demo about the container storage features that we have provided in this SODA Java release and CSI release. Once again, thank you for the demos. We will now move on to the next session, and that is going to be a panel discussion on cloud native and container storage future. So it's containers. Let's go to the next session.